For this video, for the review, we're going to look at scientific notation. So what are the requirements for a number to be in scientific notation? The first is that the factor, so that's the number out in front, has to be between 1 and 10. And remember, that's because we're pulling out powers of 10. So if you have a 10, then that means we can rewrite that number as a power of 10, just like, say we did have 10. That's 1 times 10 to the first power. So we can write that as a power of 10, so we need to make sure our first number is between 1 and 10. And then the second requirement is the factor is multiplied by a power of 10. There was a homework problem where you had to identify which one was not in scientific, or which ones were in scientific notation, and there was one that had a power of 5, and that can't happen. It has to be a power of 10. So the number was something like 4.23 times 10 to 5 to the 10th. That's not in scientific notation because that has to be a power of 10. So those are the two requirements to be in scientific notation. So now for problems 15 through 18, we're supposed to write the number in scientific notation. So remember, when you have a number, so 5,260, and you don't have a decimal, then the decimal's at the very right, okay, because there's no fractional portion in this number, so this is where the decimal is. So now we have to move the decimal so that the number is in between 1 and 10. So here, if we left the number, the decimal there, it would be 526. That's not between 1 and 10. If we left the decimal there, the number would be 52.6. It wouldn't be 2.6. You can't just look at the two numbers around the decimal. You have to look at all the numbers. So that would be 52.6, which is not between 1 and 10. So if we move it one more time, then we get the number 5.26, and that is between 1 and 10. So that's going to be our factor, so 5.26. Now, how many times did we move that decimal? So 1, 2, 3. We moved it 3 times. So since you moved it 3 times, you made that number smaller, so we divided by 10 3 times. Well, you can't just do that. 5.26 isn't the same thing as 5,260, so you have to turn around and multiply by what you divided by. So multiply by 10 to the third. And again, that's because by moving the decimal, we were actually dividing by 10 3 times. So turn around and multiply by 10 3 times so that this number is still equal to the other number. It's just in a different form. So 5.26 times 10 to the third is your answer for number 15. For number 16, we have a very small number. We could figure out how to say it correctly, but it's just point, a lot of zeros, 8, 9. So we need to write this in scientific notation. So we can see where the decimal is. It's right here. So we need to move that until the number is in between 1 and 10. So we'll count as we go this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we move it 10 times, we get the number 8.9. So this time, this number started out as really small because it has a lot of decimals to the right of the decimal place. A lot of digits to the right of the decimal place. So by moving the decimal to the right, we actually made the number bigger. If you remember the rule or the trick when you're multiplying by 10, if you take 3, multiply it by 10, you're actually moving the decimal and adding a 0. Multiply by 10 again, move the decimal, add a 0. So when we go to the right, we're making the number bigger. But it's not supposed to be that big. So I have to turn around and multiply it by a negative power of 10, which means we're going to divide it by 10 many times. How many times? We moved that decimal 10 times. So it's times 10 to the negative 10th power. Again, the reason it's negative is because the number is very small. So if the whole dividing by 10, multiplying by 10 thing confuses you, or even if it doesn't, just remember that a small number will always have a negative exponent. And by small, I mean between 0 and 1. We're not dealing with negatives really right here, but we're dealing with numbers between 0, 1, and 1, and then numbers bigger than 1. So numbers bigger than 1 would have a positive exponent, just like in number 15. So that's your final answer for number 16. Number 17, we have 9,080,000. So again, the decimal place is to the very right since we don't see a decimal. We need to move the decimal until the number's between 1 and 10. So 1, 2, 3, 4, 5, 6. So the number I get is 9.08. You got to write that 0 since it separates two numbers that are not 0. And we got to times that by 10 to the, we counted 1, 2, 3, 4, 5, 6 places. So times 10 to the 6. Remember, that's because we've got a big number. It's bigger than 1. So our exponent has to be positive because this number isn't big enough. So we make it bigger by multiplying by powers of 10. And that's your answer for number 17. Number 18, we can actually read this. It's not super small. So this is the tenths, hundredths, thousandths, 10,000ths, 100,000ths, 1,000,000ths. So this is 312 1,000,000ths. So we're going to write this in scientific notation. We can see that the decimal is right here. So we are going to move it until we have a number between 1 and 10. 1, 2, 3, 4. So if we move it 4 times, we get the number 3.12. If you moved it again, you would have got 31.2, which is not between 1 and 10. So just leave it at 31.2, or 3.12. And you can't put it 1 before the 3 because that would be 0.312, which is not between 1 and 10. So we've got our number, and we moved it 1, 2, 3, 4 times. So this is times 10 to the, is it a negative or a positive exponent? Remember, since the number is the small, it's going to be a negative exponent. So it's going to be to the negative 4th power. So those two are equivalent, except this is in scientific notation. And that's it for writing in scientific notation. I will have the next video over going from scientific notation to standard notation.